Hi, I'm Jim Sinesco. I'm the Vice President of AFC International. And today I'm going to give you a little bit of a demonstration of one of our products we've made for many, many years now. Actually, it's probably going on about almost 10 years now that we've had now the bump test station. We call this the BTS101. And the 101, Bump Test Station 101, is the quickest and easiest method, universal device to calibrate virtually any type of gas detection unit out there in the field, in the market. Whether you're using Draeger, Ray Systems products, MSA, Industrial Scientific, you name it, it doesn't really matter. The Universal Bump Tester 101 can do a good job and quickly do a good job of bump testing and making sure your instrument's working prior to use. The whole basis of it is basically a nice NEMA 4X cabinet with a flow meter, an on-off button, start button, and then a place, this little hose coming out that front end of it to provide the gas. So all we have to do really is hook up our instrument, push the button, and it pays out gas. So I'm going to go ahead and grab a single gas instrument from Ray Systems. And again, I'm just using this one as an example. This is a carbon monoxide instrument from Ray. This is called their Toxi Pro. It's for carbon monoxide. So what you have to do to make it work with your particular instrument is just take the cal adapter that usually comes standard with any gas detector, calibration adapter, and with this kit that we provide with the bump test station unit, it has all different types of fittings and lure lock fittings and tube adapters to make anybody's cal adapter work. So once you do that, inside we set the flow to whatever flow rate that your manufacturer recommends for calibration. In most cases, it's about half a liter per minute. This is a diffusion instrument, so all we have to do is take the adapter, attach it on there, put the adapter over the top of the sensor port, and turn the button on. Now the instrument is set for to pay out gas for 30 seconds. So that's settable. You can go in there and change it whatever you'd like. But 30 seconds is a real good indicator to let you know where we are and to let you know that's safe or not. If it doesn't go off at about 20 to 30 seconds, that's a real issue, and you should have that instrument taken a look at and maybe calibrated or replaced. In this case, I'm putting out 100 ppm CO, and you can see my instrument is reading right now at 101, 102 part per million, right on the numbers, plus or minus a couple there, 2 or 3 part per million. And you can see the bump station automatically shut off. And I would take the adapter off, and you can see what's going on there. You can see the instrument coming back and recovering from that. Very easy, seamless way to do it. Bump Station 101 can be mounted anywhere in the plant, except for explosion-proof areas. It does not have a classification for explosion-proof areas. So any safe zone, most instrument shops, most areas where instruments are kept is a safe zone. So find a safe zone, put it on, you'll be in good shape there. Now I'm going to go ahead and show how we would use a pump unit. As you've seen on several other videos that I've done, I am a real stickler when it comes to bump testing, especially pumped instruments. Now pumped instruments kind of require a little bit of a different setup because pumps have to pull at their own rate. This is a Ray Systems Q-Ray 2. Now you can see the pump inlet is right here. You get the sample to the sensors. But you'll also see that it's got this filter here. Now we always want to use the filters in line. However you're going to use the instrument in the field is how you want to use the bump test station prior to going out there. So what pumps have to have though is you don't want to force the gas into the instrument. If I just took this T off and I attach this, the pump's going to bog down, first of all, because I haven't turned the button on, but I'm basically forcing that gas through the instrument. And of course, even if the pump wasn't working, that gas is going to go somewhere, and it's going to go through to all the sensors, and you get a pass, a calibration pass, or a bump pass. And that's really not the intent here. We want to make sure that the pump's pulling. So the reason we use this T then is basically we can connect it up to the instrument inlet of the pump, and you can see what's happening here. The gas is going to come out the T, excess is going to go out this leg of the T, and then the instrument's going to be allowed to pull and draw gas in at its own rate. again, the advantage of this is if the pump isn't working on the instrument, which is very, very likely with pumped instruments, one of the things we got to check. Great to have, but the pump is the weak link. But if that pump's not working, and if we didn't have this T, we'd be forcing the gas in and it would calibrate, it would bump, test fine. In the field, though, because the pump is not pulling a sample in, you'd be walking around with an instrument that said 0 all the time, and everything was fine, when in fact that could be a problem. So, again, the T gives us the ability to send the gas through at its own rate, and again, the pump pulls at its own rate. So the only trick here is we have to make sure that the instrument, or the bump station, is pushing out greater flow than the instrument. Now, I checked before, this Ray Systems unit usually runs about a half a liter per minute. So I've set my bump station to run out at about 0.8, 0.6, 0.7, somewhere in that neighborhood. Once you hook up with the T, and again, all these fittings come together in the kit with the bump station, all we're going to do is hit our button, turn it on. You can see our flow rate of the gas coming out of the bump station is at 0.8. I also want to check, make sure gas is flowing out this end of the leg, meaning we provided more flow to the instrument than it needs. The excess is coming this way. And you can see, I don't know if you can see this, I got carbon monoxide in alarm, H2S in alarm, oxygen's in alarm, and LEL is in alarm. All 4 gas sensors. This is a 4-gas mix, a confined space instrument. Boom. In 30 seconds, it went off. Everything's great. My light went off. Now, I can disconnect and go do my work. Very, very simple, very, very efficient way of doing it. And again, anybody's gas detector. Doesn't matter whether it's MSA, ISC, Draeger, Ray Systems, and all the other ones out there. It doesn't matter because we're just paying out gas, and all gas detectors should be able to detect that gas. Now with the Ray unit here, it went back out of alarm. It's a non-latching alarm system, so everything's good. Let's grab a Draeger. This is a Draeger XM2000. They've just come out with a revised version of this called the XM2500. I'm excited to see what that's going to be looking like, but I think it's pretty much similar to what we have here at the 2000. It is a 4-gas meter, oxygen, combustible, carbon monoxide, and H2S. For this one, it's a diffusion instrument. There's no pump. So what we're going to do is we're going to disconnect, attach on their cal adapter with another fitting that comes with the kit. Put the instrument in the cal adapter, and hit the button. Once again, it's universal, meaning anybody's gas meter, because it's just gas coming out at a flow rate. And again, we're flowing a little bit higher than we normally do with the Draeger, but that shouldn't be a problem. And you can see here, the LEL is already in alarm at 48. I'm giving it 50% LEL. Oxygen is in alarm, 17%. That's what I'm giving it. A2 for the hydrogen sulfide at 20. And carbon monoxide at 100. So that's a pass. I could disconnect. And the nice thing is the bump station shuts off on its own. So once again, an easy, quick method for bump testing. Again, anybody's gas detector, and you don't have to be a brain surgeon to figure this out. You don't have to have the gas squirreled away in some safety office, safety department. We can't get to it. This could be on the wall 24/7. And I'll go ahead and unlatch the Draeger unit, and we're back in business. Now I can go out and do my work. So, great product, the AFC bump station BTS101 timing system, flow meter, can be used with diffusion and pumped instruments, can be any flavor. We've had it out there for a long time, but look at our website at www.afcintl.com. Certainly take a look at that. We have other types of bump stations as well, so you'll see other videos and all the different varieties of bump stations that we have available. So again, AFC wants to be your customer. We want to support you, and this is just one other way by making great products and accessories for your instruments that we feel we're going to be able to help you even better. Have a great day, and I'll be talking to you soon. Thank you.